Hi and welcome to another Carpenter Tutoring tutorial. I'm Amy and today we are going to walk through a couple examples of solving two-step equations for different variables. Two-step equations are those that contain two relationships between the variable and other numbers on the same side of the equal sign. Because we have multiple steps, we have to be concerned about the order in which we break those relationships. So remember that whenever we are solving for that variable, we have to use SADMEP to determine our order, breaking all subtraction and addition relationships first, then division and multiplication relationships, then exponents, and then any relationships inside parentheses or other grouping symbols. Let's go ahead and take a look at our first problem. I have 10 equals m divided by 4 plus 2. As I look at the right side of the equation, I see that I'm going to be focusing on getting m on its own. And there are two relationships combining m with different numbers at the moment. First, I see a division relationship between m and 4, and an addition relationship between m and 2. Using SADMEP, I know that the addition relationship is the first one that I should break because it comes earlier in SADMEP. So I'll break that relationship by doing the opposite operation. The opposite of addition is subtraction, so I'll subtract on both sides, and I'll subtract by the value that I want to get rid of. I want to get rid of the 2, so I'll subtract by 2. On the left side, 10 minus 2 is 8. And on the right side, the plus 2 and minus 2 will cancel each other out and leave us with just m over 4. Now I've completed all the addition and subtraction relationships in this equation, so I can move on to multiplication and division. I see that m is being divided by 4, and so I'll have to use the opposite operation of multiplication. Again, making sure that I do this on both sides of the equal sign to maintain balance. I'll multiply by 4, since that's the value we're trying to break m's relationship with. On the left side, 4 times 8 is 32. And on the right side, the 4's will cancel each other out. So I'll be left with just m. This gets me the answer, m equals 32. Now we can plug the value 32 back into our original equation and make sure that that equation holds true. I'll rewrite this as 10 equals 32 over 4 plus 2. I'm going to be focusing on simplifying the right side of this equation since the left side is already down to a single term. Because I'm just focusing on simplifying an expression with all number terms, I'm going to go back to using standard order of operations, or PEMDAS. There, that tells me that I have to do multiplication and division before I tackle addition and subtraction. So I'll start by changing 32 divided by 4 into 8. Then I can complete this addition. 10 equals 8 plus 2, which is 10. And 10 is in fact equal to 10, so I know that I've done my work correctly and that the value of m truly is 32. Let's take a look at our next example. I have the variable a, which is negative, and is also having 5 subtracted from it. Since we're back to solving for a variable, we're also back to using SADMEP. We know what to do with the subtraction with 5, but how do we handle a negative sign? Well, remember that a negative sign is really like multiplying by -1. So we can think of a negative sign as a multiplication relationship with a secret -1. I know that I'll want to start by breaking my subtraction relationship, since subtraction comes earlier in SADMEP than multiplication does. So I'll start by using the opposite operation, which is addition. I'll do that on both sides of the equal sign, and I'll add the value that I'm trying to get rid of, which in this case is the 5. These two 5's will cancel each other out since they have the same value but opposite operations, and that will leave us just with -a on the left-hand side. On the right-hand side, -8 plus 5 takes us to -3. Now I have to break my multiplication relationship between the secret -1 and a. I'll break that multiplication relationship using division, and I'll divide by the value I want to get rid of, which is -1. -a divided by -1 will leave the a, but get rid of the negative sign. So we'll have just a equals, and then -3 divided by -1 gives us +3. So this tells me that a equals 3. We can plug the value 3 back in for a in our original equation and make sure that everything still works out. So we would have -3 minus 5 equals -8. Well, negative 3 minus 5 is negative 8, and negative 8 does equal negative 8, so I know that A must equal 3. Last but not least, we have 8 minus 3y equals 14. I know that my goal is to get y on its own, and I see relationships between it and 3 using multiplication, and it and 8 using subtraction. I'll have to break that subtraction relationship first, but here's the important part. While we do have subtraction on the page, when it comes to breaking this relationship, the thing that matters is the sign in front of the value we're trying to get rid of. Because this is a positive 8, I'll actually need to subtract 8 to cancel it out on this side of the equal sign. So I'll be subtracting 8 from both sides. The reason for this is that my goal is always to turn that value into 0 when I'm trying to break an addition or subtraction relationship. If I added 8, this 8 that we already have would turn into 16. I'd be getting bigger instead of smaller. So in order to turn this positive 8 into 0, I have to take 8 away. So when I do that, these 8s will cancel out, and I'll be left just with negative 3y. Now this is really important because technically this 8 just turned into a 0. We would have had 0 minus 3y. Even though our 0 has gone away, the subtraction symbol stays and becomes a negative sign. So what used to be minus 3y, as in the subtraction problem where we're subtracting 3y, turns into negative 3y. On the right-hand side, 14 minus 8 will leave me with 6. Now I can break the multiplication relationship between negative 3 and y. I break that relationship with division. And I divide by what I want to get rid of. I don't want to just get rid of the 3. I also want to get rid of the negative sign. So that means I have to divide not by positive 3, but negative 3. And again, I do this on both sides of the equal sign to make sure I keep balance. On the left-hand side, negative 3 over negative 3 becomes 1, and 1 times y is just y. So we're left with y on its own. And on the right-hand side, 6 divided by negative 3 is negative 2. Finally, to check our work, let's go back to the original equation and plug in negative 2 where we had y before. So we had 8 minus 3 times y. I'll use parentheses to show that multiplication here. So times negative 2 equals 14. Now that I'm back to simplifying a numerical expression, the left side of this equation, I have to use PEMDAS again. So I'll do this multiplication first. Negative 3 times negative 2 is positive 6. So I have 8 plus 6 equals 14. And 8 plus 6 is 14. So we have 14 equals 14. That is true. 14 does equal 14. So we know that our solution y equals negative 2 must be correct. I hope it's been helpful to walk through a couple two-step equation examples together. If you have any questions or other topics that you'd like to see covered, please let me know in the comments. If you enjoy our content, I hope you'll consider liking this video and subscribing to our channel. Thank you so much for spending part of your day with me, and I'll catch you next time.